Well, hello all, I'm back again. Still haven't seen my wife, she's still missing in action in the UK. If you find her, she might be over in the French Riviera, maybe down in Spain, at that beach place. I don't know if it's that sort of weather now, but it's the only place I can guess she's at. But yeah, if you find her, send her on home. I'd like to see her again. Well, let's pick up the project. I have learned a couple of tricks as I keep viewing other people's presentations. One, these pins would be a bear to properly solder. But I learned the trick, and let's see if I can get it to do it without dropping it. But if you set it into one of these breadboards, which I'm trying to do now, and you can push it in, which this one isn't doing. No, I think I figured it out now. Let's see if I can do it this way. No, I won't do it that way. Well, anyhow, I'll figure that other bit out later. But anyhow, if you could pick it up, press it on the breadboard, which is falling apart, and push it down, and it makes it easier to solder. So I will be looking at doing that when I can find my soldering iron. It's currently out in the garage somewhere, but I'm not exactly sure where. So I'll be picking that up shortly. I said before I'd explain why I'm getting back into something I swear I never do again. There's several projects, actually a lot of projects, that I'll be picking up. The very first one is a weather station. I'm just going to write it down so I know what these notes are for. / greenhouse control. So what it's going to do is gather all the information about weather on the outside. Gather all the information about what's going on in the greenhouse. And then based on a given program set, it will triage whatever needs to be done. So for example, outside, which we'll do outside, I can spell that is. We're going to want to gather wind speed. Whoops. Like I said, I can't write. I haven't handwritten anything in years. Wind speed, wind direction, we're going to want to know what the temperature is. And I'll be doing it in C. We're going to want to know what the humidity is. In percent. Let me think. How much rain has been? I swear I haven't written in years. The only thing I ever use is a keyboard. We're going to be doing, wind speed, wind direction, temperature, humidity, rain gauge, barometric pressure. See if I'm forgetting anything. Well, if I am, I'll write it down later. For the greenhouse, and all these inputs would feed into the greenhouse, because if it's too cold outside and the greenhouse is overheating, then other actions would have to be performed because you don't want to open it to outside, because that would cause more problems. The greenhouse, and I may not have a complete list. We're going to want to know almost the same thing. We want to know what the temperature is, what the humidity is. We're going to want to know what the soil moisture is. Yep, haven't written in years. We're going to want to know the soil temperature. We're going to want to know, is that all the inputs I can think of? Oh, yeah, what the light level is up here, also under outside. What the light level is on the inside. Soil temperature, moisture, humidity, temperature. Don't care about pressure on inside the greenhouse. And these would be the various inputs. If I can't think of anything right now, I'm running blank. These are all inputs. From that, we can do automatic watering. My Sam doesn't really like that idea. She prefers to do it herself, but I'm still going to put the circuit in there for it, because if her and I go, say, to the mountains or somewhere else, and we're going to be gone for 5 days, then somebody's going to have to water this, so that will be an output. If it gets too hot, we're going to want to, I can't think what you call it, but lower the awning, the cover, or whatever it is, to reduce the light. We'll want the ability to open the vents. We're going to want the ability to engage the fans. What else do we want to do? Well, I guess that's really enough. We're going to want to know how to do all these given tasks. And this will be connected to several, I'll just put a question mark. I never could spell Arduino. However it's spelled. Nanos. I don't know the number that's going to be needed because I haven't figured out all the inputs. And it's going to use a master controller of either an Arduino Mega or a chip. Sorry, no raspberries. Not backing Microsoft people. Or not Microsoft. Well, I guess it could be Microsoft. Apple people. There will be on one of the Arduinos, there will be, I'm guessing, 2 relay shields. I'll have to think about that one. 2 relay shields. We will have one Wi-Fi, and that will be going to either the chip or the Mega. And for the Nanos, we'll be using IT I2C communication. I'm going to need, I'm guessing, at least one deep cycle battery, oops, we're going to need at least one 50 or 100 watt panel. That way it can run everything, monitor everything in case there's no power. I'm thinking the relay shields will have to work with AC and switch things on and off. And maybe DC, I don't know. If it is DC, then we're going to need more batteries for sure. And that's what the project looks like right now. I don't know if you can see the paper or not. I can't really tell through the camera. Now, the reason I said I blame somebody for this is there's a bloke by the name of Julian, and if I pronounce his name right, Julian Ilett. I think that's right. I blame you for this because you got me back into this again. I'm also going to revive I think it was Muffet, which is a Arduino MPP charge controller. Man, I know it's been years, but come on. Anyhow, I know it's a spelling error, but I don't care. All right. Now, I looked at Julian's presentations like 5 times. And I also saw another presentation, which I can't find to send him. But there's a bit in one of the Arduino registers that can cause a shift within the frequency of the PWM pulse to where it would exceed the prescribed percentage, and I think it's by 3% of a pulse width. And also, additional problems in the code is if all the computations take longer to create the pulse width, can also cause jitter in the pulse width. So I'd like to find that register because I'm going to need to know it anyhow. Now, for me, and this is not Julian's requirements, I would like to have up to 150 volts DC coming in for 4K watts. And I'm going to be wanting to convert this, well, not in the prototype will be 12 volt only, because I'll have to figure out how to do the rest. It will be for 12 volt, 24 volt, and 48 volt. There's also a bloke that I know in Texas has been after me for 3 years to build this thing. And I keep putting them off, and I think he gave up asking, but I'm going to start working on it again, but not tell him about it. Now, this is the requirement that I'm going to try to meet. Now, working with electronic circuits as I have throughout the years, I have my own take on things. So, given this number here, and I'm not sure about what I'm going to say next, it might be a little higher, it might be 80. But it's like 60 to 80 amps going to the battery. So, what I've considered doing is this, because it makes components a lot easier to procure. I'm not saying it's the best way, but but it's a more simple way to get it. There'll be a input board, is what I'm going to call it. That's where all the solar merges into. And then you're going to have an output board that goes to the battery. And I'm also going to add something that's only used on wind, which is called a dump load. And let me explain why. When you have a set of solar panels and they finally get the battery up to float, all they're doing is giving trickle charges to the battery. So it's not really utilizing the panels to its fullest capability. Because if you have a set of batteries, let's say you didn't use it, or you're away, or whatever, and it only takes, say, 2 hours of the day to charge, and you could be missing 5-6 hours of sunlight that you're not utilizing. Yeah, granted, when the sun starts heading down, you're not going to get much power, but you're still getting something. So all that power is just going to waste because you're not bringing it in. And the solar panel stops collecting it, waiting for somebody to discharge it. So I want to put a dump load in. And I want the dump load to activate for 5 seconds, which will disconnect from the battery, and they'll go into a bank of supercaps, which will in turn go into a GTI or grid tie inverter, which could feed the house. So the way to get around this, and like I said, it's probably not the best way to get around it, but it's the only way I could really think of. That's why I broke this down into 3 separate boards. Is to do this. We will divide the load of the entire power coming in. And we'll just say 8, just assuming it's 80 amps. So we'll have a total of 8 microcontroller buck converters. But 4 of them will be in phase. And 4 will be 180 degree out of phase. So that means that the pulse width modulation from any controller is no more than 50%. This way, the circuits can either create the voltage needed for the battery, or you're dumping the voltage they had for the battery and they're basically switching off. So the power is more continuous and steady. So we're going to need also measure. We're going to need to measure V in, V out, I in, and I out in this device. So we can make the phase corrections in the pulse width. And I believe the Arduino can probably handle this, although since I'm using so many variations of it, where there's a number of probes, I don't think this given chip here will be able to handle that many ins and outs, at least not without a lot of circuitry. Might be able to do it with an I2C and use an external voltage and amp monitor, which is a possibility, instead of using the one built in on the chip, and then re-rig the chip to run through a set of registers to accumulate with the voltage in, voltage out, and amp in and amp out in order to compute the pulse width. So that might be a possibility. Well, that's the two projects, and I really blame Julian for getting me back into it. But like I said before, there's a bloke I know out in Texas that really wants me to do this, and has for years. And that's what got me back into this. Because I was looking at a lot of things Julian was doing, and it wasn't wrong, really. It just, there was things I probably wouldn't have done. I mean, electrically he was right, but methodology we differ on. So I got a couple of better ideas on it. One is to have separate control, well, for this design, not for his, but to have separate controllers that are both in and out of phase. And I'm not sure if I can externally clock that or not, which might make it easier to keep everything in time and sequence. Otherwise, I'm going to have to do one controller, I have to do in phase and out of phase in 4 sets, which means I could end up with 4 nanos and 1 mega to run the display and controller. And these would just talk through I2C. And I might also install a Wi-Fi card in there for data logging, and also for monitoring. Could also probably do control too, but I'm not sure what control I would do, because past the default configurations, I can't think of more configurations I would set it for. But the guy I know in Texas also wants to add in a 220 volt AC inverter to this. Man, I wish I could, well, forget it. We'll just say that. I can't write anymore by hand. Which will be different than what it is throughout most of the world. Here, what you have is you got 3 lines for AC. You have L1, you have neutral, and you have L2. And L2 is 180 degrees out of phase of L1. So the voltage potential between these 2 points is 220. But the voltage potential between these 2 points, or this 2 points, is, well, 110, 115 really. So here we got this idiotic design, which makes it hard. The rest of the world, it's real simple. You have L1 and you have neutral. And they already got the device I'm thinking of. It's actually manufactured by a company out in Singapore, I think it is. They already got it. But we can't use it here because the way the circuitry is designed. And the key behind the circuitry is no transformer. Which makes that thing heavy beyond your wildest dreams. You get a big, huge 1-to-1 transformer that is at least 85% of the weight of the entire thing. And it's probably 85% of what's actually in it. The rest of the stuff can be done real simply. But because those transformers are so large, and maybe what it takes to drive it, it's insane. But that's the two projects. A weather station and a greenhouse controller, which will be tied together at the same place. And I'm going to revive Muffet and continue the work on it. And I have other projects after this, but right now, these are the two main projects I'm going to be focusing on.